Hello everyone, it's Drew Castro and Tommy Rodriguez.
How you doing?
We did our physics project on how changing the wavelength of a string, specifically a string on a guitar, changes the frequency. Now, when you play guitar, you can pluck the strings. When I pluck the E string, we hear the frequency coming from the wave of the string, and the frequency we hear is the note E. We hear frequency as pitch. So when I put my finger higher on the string coming off of the guitar on a higher fret, which is what this piece of wood is divided into, frets, each of those notes was higher than the last, but I'm shortening the wavelength. Simply by changing the wavelength, we can assume that we are changing the frequency just by this simple motion. In order to prove that is what is causing the change in pitch and frequency, we found 6 different pitches on the E string, and we found what their frequencies are. We are only able to prove 3 of them, given the fact that we were only able to acquire the sounds for 3 of them. All of them are accurate, all of them have been proven through the equation. Frequency times wavelength is equal to speed. Now, in order to prove to you that these are accurate, we're going to play 3 of them now. We're going to play E, G, and A on the E string, which is the first string on this guitar.
Okay, this is for E. Now this is for G. And now this is for A.
As you can tell, each of those notes were progressively higher, specifically on the string that I'm playing, but they were also higher in pitch. The frequency of E alone is 82.41 hertz. The frequency of G is 98 hertz, and the frequency of A is 110 hertz. Those were the 3 sounds that you were hearing on the speaker. Now, because we know I'm playing higher notes, they are making higher frequencies. Each of those frequencies, not only was the notes progressively higher, but those frequencies were progressively higher. But I was progressively shortening the wavelength. From this fact, we were able to determine that shortening the wavelength is what's changing the frequency. Shortening it is increasing the frequency.
And so, we found that the wavelength of the wave by multiplying the length of the string used by 2. Now with this, we were able to find the speed of each wave, and it was approximately, each wave had a speed of 109 meters over seconds, and so this is how we know our numbers are accurate.
Since all of the pricks were moving at the same speed each time, each of those waves were moving at the same speed, but they had different wavelengths, the only other part of the equation, wavelengths times frequency is equal to speed, the only thing that could have changed is frequency. So when the frequency is decreased, the frequency increases to maintain the speed, and that's exactly what happened here. We are not taking into consideration the weight of the string, because that was something we could not do with the time that we had and with the resources that we had, but that is why we found the speed specifically, so that would not be an issue. As for our project as a whole, I do believe that is all we have to share with you guys, and we'll see you in class.
Bye everybody. Hey, ah!